Hello everyone, this is Dr. Carlos Garela Zarco. Welcome to a new session in your module Big Data and Business Analytics. Today, the topic that we are going to cover is data visualization. Here you have the main learning objectives for that session. The first one is that you understand the importance of data visualization, that you learn which are the key aspects of data communication in order to make better visualization for your data. And finally, we will explore different techniques and some good practices to visualize data. Well, first of all, I would like to give you some context about data visualization. The first things that people imagine when we talk about data are numbers, labels, categories organized into rows and columns. And maybe you know the quote that says that a picture worth 1,000 words. So for data is similar. By looking at picture, in particular picture of data, is awfully much more important than looking at the raw data organized in spreadsheets. So visualization is an important part of the exploratory process, and it's going very helpful in order to identify outliers, in order to understand the type of data transformations that we need, and many times visualization is the best way of generating the better ideas for building our analysis or models. So based on the previously said, data visualization is a priority when learning to work with data. And that's the reason because we are covering that topic here today. Well, we mainly can distinguish two types of motivations for using data visualization. The first one is the comprehension of dense information. It's clear that by using a simple visual chart, you can easily include thousands of data points. And by using visuals, the user can see the big picture as well as longer term trends that are extremely difficult to interpret purely by expressing data in numbers. The second main motivation is to find relationships. By visualizing data in Cartesian coordinates, we can explore the relationships between different variables. And also representing more than three attributes on the x, y, and z axis is not feasible in Cartesian coordinates. There are a few creative solutions available by changing properties like the size, the color, shape, or using flow maps, where more than two attributes are in a two-dimensional medium. What is pretty clear is that visualization is pretty useful and influential. If you see this data set, maybe you are not very familiar with that, but I'm pretty sure that you are very familiar with this visual representation. This is for sure the most famous data representation nowadays. This is the curve that shows the incidence of coronavirus. And here in this map, you have a representation of the incidence on a territory, particularly in the UK. So maybe some people are not going to understand this data set, but I'm pretty sure that many of them can understand this curve, and I'm completely sure that they can understand this map with colors. So it's clear that data visualization makes data understandable for everyone. And the second important aspect is that by making data much more understandable, we are helping people, like politicians, in making data led decisions. Now, I want to show you how powerful visualization of data can be. And to illustrate that, I would like to use this quote by John Wilder Tarkey, who was a mathematician who created the term exploratory data analysis. He said that the greatest value of a picture is when it forces us to notice what we never expected to see. This is about to show hidden pattern, but also this is talking us about the power of visualization to show aspects and trends that we are not expecting from the data. And here, for example, you have an impactful representation of data. Probably you know that we all are addicted to drinking water from plastic bottles. And this has turned into a huge garbage problem. This visualization shows the piles of plastic bottles in relation to famous landmarks and cityscapes. So obviously this graphic does a great job of making a statement about how we are covering the earth in plastic. That example could be even controversial, but I want to show you because not many people can manage to create beautiful things with unfortunate data and information. This is a beautiful visualization, but tells the story of all the people who took their life in the Netherlands in 2017, and each natural symbol represents how life was lost, along with the side representing age. So sometimes the best data visualizations are the ones that tell an impactful story. And here you have a third example. This is about Hollywood films. And here it shows the percentage of budget recovered in relation with the average critics. But if you look this graphic in detail, you may be surprised of very good films not being very profitable, while other silly films, not well reviewed by critics, achieve an impressive profitability. Okay, now we have already contextualized the importance of data visualization and its power. But here we need a more formal definition about what data visualization is. We can define data visualization as the act of taking information, data, and placing it into a visual concept, such as a map, or a graph, or a chart, etc. Data visualization is a field that has inputs from many diverse disciplines, like psychology, visual perception, art, etc. As a discipline, visualization gives importance to the impact of some elements on perception, such as color, shapes, etc. On the other hand, the use of several disciplines in the design of data visualization artifacts is a reality. And in fact, the use of principles, concepts, techniques, and theories come from multiple backgrounds, such as programming, web designing, semiotic, or psychology. And maybe the main aspect of this session is that you realize the importance of data visualization. Data visualizations make both big and small data sets easier for the human brain to understand. And also it makes easier to detect patterns, trends, and outliers in groups of data. So the main objective of data visualization is to place meaning into complex data sets so that their message is clear and concise. And as we said before, graphical visualizations of data could show unexpected value. So they are the potential to show what we are not expecting to see. But data visualization is not only good for data exploration and discovery, but also for communication and sharing your insights with other people. And this is a key factor. Also, with the increasing growing of big data, which is quite difficult to understand as a raw data, visualization is becoming a key tool to make sense of the trillions of rows of data generated every day by, for example, the Internet of Things. In addition, the results from complex algorithms are much easier to understand in a visual format than obviously trying to show it through lines and lines of text, coding, or numbers. Finally, it's important that you understand that data visualization helps to tell stories. It means that makes data easier to understand by highlighting the trends and outliers. A good visualization tells a story, removing the noise from the data and highlighting the key information. Another important aspect of data visualization is that this is holistic. Sometimes, particularly in business, we use numerical summaries. With visualizations, we can actually show every single observation, every single data. And a final aspect to take into consideration is that visualization makes the differences much more clear. Now, I want to show you the importance of data visualization by using a classical example. Ensembles quartet can be defined as a group of four datasets which are nearly identical in simple descriptive statistics, but there are some peculiarities in the dataset that fools the regression model if built. They have very different distributions and appear differently when plotted on scatter plots. But if you look the dataset, for each one we have two variables, and if you look at the summary statistic, the descriptive statistics, in terms of population, mean, standard deviation, and R, you can observe that they are identical or almost identical. Here's the first dataset. This is a scatter plot, and you can see that we have got this line going up in the middle. That's our regression line. And we got these dots that are scattered around a little bit. So this is what we expect to see when we were looking at data. However, in the second dataset, you can see that this is describing a perfect curve pattern. So we can draw a straight line through it, but the straight line doesn't fit it right. However, based on the summaries, the statistical summaries that we have, it is identical in many ways. Then, from the third dataset, we have this other pattern which describes a perfect linear relationship, except for this one dot showing way up at the top, which appears to be an anomaly. Maybe it got recorded wrong, or maybe something strange is going on there. The fourth dataset is a very strange dataset. In this one, we have all these dots on the left, where they all have the same value on X. And then you got one way off to the right, an enormous outlier. So these four datasets are obviously very different from one another, and by looking at them, it's really easy to see, even though it was hard to tell by simply looking at the descriptive statistics. So the dataset number 1 fits the linear regression model pretty well. The dataset number 2 could not fit linear regression model on the data quite well because the data is non-linear. And datasets 3 and 4 shows outliers involved in the dataset which cannot be handled by linear regression model. So the conclusion here is that we are describing 4 different datasets that were intentionally created to describe the importance of data visualization and how any regression algorithms can be fooled by the same. Therefore, all the important features in the dataset must be visualized before implementing any machine learning algorithms on them. And visualization will help us to make a good fit model for our data. So the advice is, please always visualize your data before implementing any further analysis. Now we are going to look at different kinds of graphs, and we can provide a simple classification of graphs. The first one are graphs for categories. This is when we are going to count how many cases or observations there are in a particular bucket. Those graphs include bar charts, grouped bar charts, and P-charts. They are three very common tools. Other category of graphs are the ones used for quantities or things that you measure on a scale. This category would include dot plots, box plots, and histograms. And then we have a third group in which we include visualization that work well for looking at the association between variables. This group would include line charts, spark lines, as well as scatter plots. They are very basic and fundamental things, but this type of visualizations are going to give you an enormous amount of insight into the data that you have. Obviously, nowadays we have access to literally hundreds of types of visualization. Here you have some examples, from density plot to brainstorm to bubble chart, dot matrix chart, heat map, parallel sets, network diagrams, illustration diagrams, radar chat, spiral plot, span chart, sunburst diagram, stream graph, many different types of visualization. So we can look at each of these different type of charts and see what kinds of questions each one of these charts can answer. So the important thing is what we are expecting to show. So we need to understand what to look for when you create the chart. Where are the most informative elements in it and how to interpret the results of that. But also we need to know how to apply them, how to get something actionable and useful out of the data that you got in a very basic chart. And as I say, it's always important to begin by simply looking, see what's there, do some basic graphs, and you'll get the overall picture of your data. And potentially, you can discover some surprising insight that can guide you in further analysis. So, choosing the right type of visualization is a complex process, and it mainly depends on what you need to show. Is that a comparison, distribution, composition, or relationship? How much detail the audience needs, and what information the audience need in order to be successful. Also, the amount of data visualization options may be overwhelming, but whichever you choose will be much more comprehensible than raw numbers alone. Here you have this diagram that can be very helpful on deciding which type of visualization you need for your data. And also on Moodle you can find a chart called periodic table, which is also very interesting and useful to decide what kind of visualization you can use. And finally, I would like to give you some insight about what makes a visualization good. Here you have a couple of examples about penalty analysis in football. I suppose that you can clearly differentiate which visualization is good and which visualization is not so good. Obviously, on the left, we have a confusing visualization, which is not providing the information, which is not communicating the information clearly. However, on the right, you can see a good visualization. So, a good visualization should establish mainly two aspects of the data being presented. The first one is to show connections within the data that are too complex to explain with words. This is a key factor. And the second one is to make it easier for the audience to quickly understand the information presented and consider the outcomes from that data. Usually, the complexity comes from the number of observation categories, usually different variables, along with the data type, if the data is numeric or categorical. So, for example, a visualization for displaying a statistical distribution of numerical data is usually a histogram or box plot if there is interest in its modes and outliers. But a visualization for categorical data should display frequency distribution and skew. So here you have a few rules of thumb for creating powerful and good visualizations with your data. Don't forget that the focus is on illustrating the concept behind your data. So you need to consider how your figures and background contrast. It was the problem on the picture that we saw before for the penalty example. So here the standard rule is to have a gradient in similar shades for online observations, but you may want to have a version with different patterns if you know the audience will likely print the graph. Also, identify accepted thresholds for each variable. Doing so provides a benchmark against past performance, and you can provide guidance on how to avoid displaying misleading differences between categories. Include label chart with numbers, but not to the extent that the details become overwhelming. Low numbers are usually hard to view. Use a shorthand recognizable when accuracy to the higher degree is not important. For example, the value 10,523 could be shown as 10 key on a bar graph. And finally, where possible, sort data by value to emphasize scale, but be careful not to distort the difference between categories. And finally, here you have the main conclusions for that session. The first one is that visualization is a key part of the exploratory process, and for that, this must be a priority when learning how to work with data. Visualization responds basically to two main motivations: the comprehension of dense information and the identification of relationships. Data visualization is a powerful tool of communication and helps in data-led decision making. The main objective of data visualization is to place meaning into complicated and big data sets in order to make the message clear, concise, and insightful. To choose the right type of visualization will depend on what you need to show, how much detail you need, and what information the audience need in order to be successful. And finally, a good visualization should establish two main aspects of the data being presented. Show connection within the data that are too complex to explain with words, and make it easier for the audience in order they can quickly understand that information. This is all from me. Thank you so much for your attention, and I'm looking forward to seeing you all in our synchronous session. Goodbye.